Hey everyone, today I will talk about the difference quotient. So I see many times the students, they have some difficulty understanding the concept of difference quotient. So we'll talk about that. So in general, when we see the formula for the difference quotient, okay, I'm going to write DQ, that's the abbreviation. This is f of x plus h minus f of x divided by h. So in general, students, they don't like the part of f of x plus h. So for example, if we are given a function f of x is equal to 2x plus 1, so that's a linear function. So it means that we will get a straight line when we graph it. But when I ask a question that what is going to be f of x plus h, I see too many different answers from the students, and that's the most confusing part in the difference quotient. So some students, they say that this is 2x plus 1 plus h. Oops. 2x plus 1 plus h. Some students, they just say it could be 2 times x plus h. It depends, I don't know, with different ways actually they say different things. This is even difficult for me to comprehend. But I asked them a question, and that's a very simple question for the understanding purpose. I asked them, if I ask you a question, what will be the value of f of 2? So they will easily solve it. They will say that this is 2 times 2 plus 1. And then they will say that, well, this is equal to 5. So I asked them, well, instead of saying 5, you just say 2 times 2 plus 1. Similarly, I asked them what is going to be f of alpha. So they will say 2 times alpha plus 1. I asked, okay, what about f of 1 million? Assume that m. They will say 2 times 1 million plus 1. I would say that, what about f of blah blah blah? And they start laughing and they say that 2 times blah 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 plus 1. So that's the main idea. Whenever we need to find some function value, whatever your x value, you just plug it. So f of x plus h, in this case, this is going to be 2 times x plus h plus 1. So what we have done, we replace x by x plus h everywhere on both sides of the equation. Now we can simplify it, and we can say that this is 2 times x plus 2 times h plus 1. Now we can apply that to the original formula for the difference quotient, which is f of x plus h minus f of x divided by h. So f of x plus h, we just calculated that this is 2 times x plus 2 times h plus 1 minus f of x. We are given this f of x, which is 2x plus 1. Here students, they make a mistake when they don't use the parentheses. So if you have a negative here, make sure to use parentheses. It's a common mistake. Students, they forget. When they forget the parentheses, they make a mistake here. Okay, be careful. Okay, now we can simplify, and we get 2 times x plus 2 times h plus 1 minus 2 times x minus 1 divided by h. Okay, the function of x will always be cancelled out. our function of x is 2x plus 1, so it must be cancelled out completely. So this is going to be 2 times h divided by h. So now you can see that h could be cancelled out and your answer is 2. Well, now the question is, what is this 2? Well, it will be always your slope, because if you see this function f of x, which is equal to 2x plus 1, so this is in the slope-intercept form. So 2 is the slope and 1 is the y-intercept. Okay, so your difference quotient is actually the slope. Okay, now how we got this formula, just to get some idea. If we have a function, a nice function, okay, how do we know that this is a function? Because we can apply a vertical line test and assume that you have a point here x, and corresponding to x you have f of x. So we say that, well, there is a small change in x and we call it x plus h. So corresponding to x plus h, assume that this is f of x plus h. Now we know that our slope in general, this is y2 minus y1 divided by x2 minus x1. So in this case we can say that this is f of x plus h minus f of x divided by x plus h minus x. So you can see that this is f of x plus h minus f of x divided by h, and this is your difference quotient. Well, the question could be, why we need a difference quotient while we can just see directly from here that our answer is always the slope? Well, the question is that you will not be facing a straight line all the times. Sometimes we see some complex functions, sometimes very complex functions, so it depends. So for example, I say that we have to find the difference quotient of 1 over x. Okay, so in this case f of x plus h is going to be 1 over x plus h. And when we find the difference quotient, so we need a difference of f of x plus h. So this is 1 over x plus h minus 1 over x. So, well, if you don't like fractions, you won't like it. So you know that to add two fractions, we always need add or subtract, we need a common denominator. So we are going to multiply and divide by x here, and we will multiply and divide by x plus h here. So we will get x minus, again be careful, got negative outside, so you have to use the parentheses, divided by x times x plus h. So you can say that this is x minus h divided by x times x plus h. Now x could be cancel out, so we get negative h divided by x times x plus h. So that's the difference, and this was equal to f of x plus h minus f of x. But the difference quotient is when you divide it by h. So we can divide both sides by h. Okay, so now we see that we have a formula. If a fraction is divided by a fraction, okay, let me just write it here. If a over b, so we can change this division into multiplication, and we can say that this is a over b times d over c. So you note that the denominator is flipped. So that's what we are going to see here, that this is h over 1 actually. So it's going to be negative h divided by x times x plus h times 1 over h. Now this h and this h, they are cancelled out, and your answer is negative 1 over x times x plus h. Well, you can see that it's not easy to see the slope of this function, and as compared with the one which is linear. So difference quotient actually from here, when you take the differential calculus, you will see that the difference quotient, they are everywhere. The only thing you have to do is just you apply the limit, and actually we will be having a video on limit soon, and I think that's all we have here for the difference quotient. I hope you got some idea about the difference quotient, and we'll see you for your next video. Okay, have a good one. Bye bye.